Imagine a bridge which is perfectly fine from the outside, but is slowly rusting from the inside. Steel corrosion repairs cost billions of dollars around the world. Marine structures, bridge decks, and areas exposed from the salts are heavily required maintenance. This has led this has led us to create this study for comparing steel rebars and GFRP rebars, which will help us distinguish which of them is better. Concrete is one of the strongest construction materials in terms of compression, but it falls weak when we talk about tension. And that is why we use reinforcement bars or rebars to counterattack to those tensile forces. Well, they work on two basic concepts. The first being stress, which we find out by the formula sigma is equal to F by A. It gives us how much force acts on a unit area of the material. Second comes in the Young's modulus. It gives us the basic overview of how flexible a material is. Let's say the steel rebars have a Young's modulus of about 200 GPa, while the GFRY rebars have a Young's modulus of about 40 to 60 GPa. This means rebars bend much less than the steel rebars under the same load. To understand these differences practically, we carried out a series of tests on steel and GFRP rebars. We carried out bending tests, corrosion tests, and weight tests to evaluate their mechanical behaviors. During the experiments, we recorded values of load and deflection, then used physics formulas to calculate stress and compare the performance of both materials. This allowed us to connect theoretical concepts with real experimental observation. The results clearly show that each material has its own strength. The GFRP rebar completely resisted corrosion and it is ideal for harsh environments like the marine buildings, bridge decks, or areas exposed to de-icing salt. And it also has a greater strength to weight ratio because it is much lighter than steel. And on the other hand, we can see that steel is much more ductile. So it gives us a clear warning before breaking when it bends. But GFRP, on the other hand, completely snaps off like a brittle structure. And thus, we can say that GFRP is better. Although steel has a reduced or lower initial cost, but GFRP also gains on that because of the low maintenance that it poses. Based on these findings, GFRP rebars are already being used in marine structures, chemical plants, water treatment facilities, and coastal bridges, where corrosion is a major concern. However, GFRP rebars also has its limitations. Its lower stiffness and brittle failure behavior means that it cannot completely replace steel in every application, especially where ductility is important, such as in earthquake resistant structures. Therefore, engineers select the reinforcement material based on the specific requirements of each project. In conclusion, this project shows us that neither materials are universally better. Steel provides excellent stiffness, ductility, and lower initial cost, while GFRP offers outstanding corrosion resistance, lightweightness, and long term durability. And thus, instead of replacing steel everywhere, GFRP should be used only where its advantages are most beneficial. In future, hybrid reinforcement systems wherein steel and GFRP are mixed and used could be helpful, stronger, and safer ecosystems, wherein sustainable structures are more often seen. Thank you.